Good morning, everyone. My name is Pushpajyoti Dudala. Today, we are going to present my project on CKY parsing. What is CKY parsing? Why we are using it? All we're gonna learn about in this project. Now, let's deep dive into this project. First, what is the purpose and description of my project? Why we are using the CKY parser? What is the use of it? Here, we are using CKY parser because in our language there are sentences. We need to know whether these sentences or belongs to our language or not. We can do it. We can tell whether the sentences were present in our language or not. By oral, we can't tell. There are certain rules. By using those rules we can decide whether the sentence belongs to in our language or not, and those rules are nothing but context free grammars and Chomsky normal form. All those are rules. By using those rules we are going to tell whether the sentences belongs to our language or not. Here we selected domain is computing questions. There are a lot of questions present in the students' minds about the programming, about the object-oriented programming, about AI, machine learning. We took all those questions. We'll verify whether those questions is belongs to our language or not. Here I have 15 valid sentences, 3 invalid sentences. We'll check each and every valid sentences, and invalid sentences will make sure why it is valid, we'll make sure why it is invalid. We'll do everything here in this project. First, I already told you there are some rules. Based on the rules only, you have to tell whether the sentence is accepted or not. You can't orally tell it is accepted, it is not accepted. There are some rules, and you have to follow each and every rule. First, let's what is context free grammar? Here, context free grammar is a grammar in a is a formal language which is used in the languages. Here, why we are using it? Here, by using this context free grammar, we are derives. By using these rules, we derive the sentences. If the sentence is derived by context-free grammars, then we can surely say that this sentence is belongs to our language. Here, how we derive this context, how we derive those sentences. We can derive those sentences by using some rules. All these are rules. What is as, what is auxiliary. Here, I'll tell you. Context-free grammar has 4 components. First, non-terminals, terminals, production rules, starting variable. Here, S is non-terminals in LH, and there is one important rule in LHS side. Always need to have one non-terminal, and we can't have terminal also. You need to have only one non-terminal. In RHS side, it depends. You can have both. You can have neither, nor anything. But in a LHS, you need to have, or you have to have only one non-terminal. Third, there is one LHS, one RHS, and yeah, by using these rules we are going to derive our sentences. And non-terminal, why it is called non-terminal? Because it's keep on varying. There is no termination. We can keep on substituting. There is no terminal. In terminal, we can't substitute. It's the end. It's termination point. That's why we call those as terminals and those as non-terminals. And here it is product. What are production rules? In order to go some place, we need to use some rules. Those rules are called production rules. And starting variable. Here, starting variable is very important. We'll learn about starting variable in CKY parser. Now, what equivalent of CNG in Chomsky normal form? You have a doubt. Why can't we apply it directly on context free grammar? Why we need to have CNF? Here, CKY parser is only applied on Chomsky normal form and GNF. These two forms only we can apply CKY parser. With anywhere else we can't apply. So we need to convert this C context free grammar into Chomsky normal form. First, how to convert it? It's very easy. There are only 5 steps. First one is remove all null productions, remove all unit productions, remove all useless productions, binaries all rules with more than 2 symbols on LHS, sorry, on right hand side. Isolate the terminals that appears with other symbols into separate unit rules. What is removed? What is eliminate null rules? Wherever null is present, we need to eliminate, but by substituting in subsequent symbols, whatever symbols which are using null, just substitute there. Then we can eliminate those. But I can't show you here because there is no null symbols we are taking here. Remove unit productions. Here, what is unit productions? Why we need to remove it? We can only say the grammar in Chomsky normal form only if in right hand side both are non-terminals. But if you have one non-terminal, we can't say that is in Chomsky normal form. One non-terminal is nothing but unit production. We need to remove that unit production by substituting the terminal values of that unit production. We we can only say grammar is in CNF whether we both terminals or non-terminal. If you can have one terminal, only one terminal is accepted. You can't have two terminals also, only one terminal is accepted. Useless. What is useless productions? Useless productions is nothing but the productions which are not useful. It is there, but we can't use those productions in our grammar. Then just remove it. If we have three non-terminals, then make sure you convert into two non-terminals. That's what it meant. Binaries all the rules. Isolate terminals that appears with other symbols into separate unit rules. See, I already told you it has three non-terminals, so make it two. That's how we did. We have to do. That's how. Now I told you we are tell whether the sentences belongs to our language or not. How we tell it? We tell it by using CKY parser. And CKY parser uses CKY parsing table. Now let's learn about the CKY parsing table. Here, first one is what is machine learning algorithm? We need to know what is machine learning algorithm. Sorry, we need to make sure whether this machine learning algorithm is belongs to our sentence or not. So here, what is the machine learning algorithm? How many words are present? Here we have five words. What is the machine learning algorithm? All five words. Since it have five words, you need to make the table of five row table. Here it's not fixed. You can only have five. You can have five, six, eight, nine. It's not restricted. You can have any number of rows and columns. But how many number of words are there in your sentence? That many rows and columns you have to draw, not other than those. Since it has five, I draw five rows. Now let's come to this after completing all the explanation. Then you can understand why it is accepted. First, let's take length 1. Let's take length 1. What is why we are first here in Chomsky in CKY partialities rule. First, fill whatever the words. What is the machine learning algorithm in the diagonals? Fill what here? Fill is here. Fill the here. Fill machine learning here. Fill algorithm here. First, you need to fill what is the machine learning algorithm in the diagonals. First, fill diagonal. First, what? Here, what? Here why you are taking verbs, here why we are taking verb, here why we can taking that, here why we are taking three symbols. Now let's talk about that one. Here what, here I already told you we have rules. By using those rules we are deriving our sentences. First we'll check in our language whether we can represent what or not. Yes, we can represent ox what by using ox. See, I'll show you. See, by using ox, we can represent what and it can. So here, what is represented by using ox? Is represented by using verb. The we can represent by using did. And machine learning. Here, why we are using three? Can't we take one? No, we can't take one. Here, why we are using three means machine learning is represented by three. Noun, nominal, and pay. If we restrict it to one, in the future you use this cell. If you restrict it to this one, you may not get the results what we wanted, so you have to take all three forms. So you have to take noun, nominal, np. And cell algorithm also, it can be represented by three: noun, nominal, and np. So first we got the diagonal ones. We got the diagonal ones. Let's fill the diagonals with augs, verb, det, nominal, NP. Now nominal, NP. I already told you we have to take all three ones. Now let's go to pero. Let's go to, we completed one length. Now we have to take two length. Length. Sorry. Sorry. Now we have to take two length. Cell 1 comma 2. Here no. Now we are taking two length. We'll check whether what is derived by our longest or not. What is divided by using our rules or not. We'll check what is. Now let's go. Cell 2 comma 2. Verb. Sorry. Pair of words. Cell 1 comma 2. What is here? We are splits. We can't just check what is derived or not. Here we use a split. First we'll split what, second we'll split as is. It's not restricted, you have to split at one. In the below we'll see how to split. Now just remember, we split at one, we split as two. Here what can be represented by using augs, verb can be represented by using verb, but there is nothing in our grammar we can represent what is. No rule we can represent augs and verb. So we'll take by. It's here you can take any symbol. It's not restricted to take this symbol only. You can take any symbol. It's up to you. You can take pi, you can take slash, any symbol you can take. Now that's now let's take, we completed what is. Now let's take 2 3. Is there any word in our grammar we can represent is the? We can represent is, we can represent the. Let's check by combination we can represent or not. Again, split at 2, 2, 2, 2, 3, verb and that. There is nothing in our rule. We can represent who these the. So let's take 5. Now 3, 4. The machine learning, split at 3, split at 4. The machine learning. The we can represent it by using that. Machine learning you can represent it by using nominal. So that and nominal you can represent by using NP. Here we'll check 4, 5. Machine learning algorithm. We'll check whether machine learning algorithm is represent. Machine learning we can represent, algorithm we can represent. By combination, we'll check whether we can represent machine learning algorithm or not. First split at 4. First take machine learning, then take algorithm. You are new. We have to take all the combinations. I took all the combinations. For algorithm also I took all the combinations. First, if we take one combination, suppose you thought I'll take noun only for this one. And for this one also you thought you take noun. But there is no rule. We can represent noun and noun. Then we have to take empty here. So that's why we can't restrict ourselves to one terminal. Sorry, one non-terminal. You have to take each and every non-terminal which are present, because in the future we don't know what other possibilities are. So just take it, and here take one value from here, concatenate with every other value. Now nominal, there is nothing we can represent. Nominal noun, there is nothing we can represent. Nominal NP, nominal NP also we can't represent. Sorry, nominal noun we can represent by using nominal. Now nominal we can't represent. Noun nominal. Noun we can't represent. Noun NP we can't represent. NP nominal we can't represent. Now NP noun we can't represent. NP we can't represent. But we can represent nominal noun by using two ways. One is by using nominal, second one by using VP. I already told you, take every possible combination. So I take these two. Now we completed length 2. Now let's go for length 3. I already told we have to come like this. I completed length 1 diagonally, length 2 diagonally, now length 3 diagonally. 3 words. What is the? I told you there are so many splits. We can't restrict ourselves to one split. First, because we don't know, we can get split, answered split 1, split 2, split 3, we don't know. So take every split. I split at 1, 1. Actually, yeah, it's recording. It's 1, 1. Here, 1 cup. What we can represent by ox, but is nothing in the rule we can represent is the. So we'll take empty. and there is nothing in our rule we can represent ox and empty, so I'll take empty. Similarly, I can't represent what is, I'll take empty. And I can represent it, but there is no way I can represent null and that. So I'll take empty. See, first I split. I'll take what? I'll take is the. Then I took is the. Next time I'll check whether I can represent is what is. So I took the separate. Like how you split it. Now split it k equal to now cell 2 comma 4. Now we have to take three words from cell 2. So is the machine learning, we'll check whether we can represent is the machine learning. Split at k equal to 2, 2 comma 2, 3 comma 4, verb into np. Sorry, first we'll take split at 2, we'll take is, and second last we'll take the machine learning. Whatever the left, you have to take that one. The machine learning is left, the machine learning, so you took it. Is, we can represent it by verb. The machine learning, we can represent it by np, and we can represent it is the machine learning by using vp. Now since you got the answer, you can't relax. You have to check whether is there any other options I can represent. I'll check with is the, and whatever the left, I'll took the left remaining ones here. So you took is the, what is left? Machine learning. So you took machine learning, but there is nothing in the world you can, in this here you can represent the is the. So empty. Machine learning you can represent by noun, nominal, np, but empty and noun you can represent, empty and nominal you can't represent, empty and np you can't represent. So I have to take go with first one. Now 3,5, the machine learning algorithm. You have to take from three words, the machine learning algorithm. Now split it three. First took the separate the and machine learning algorithm separately. 3 comma 3, 4 comma 5, 4 3 comma 3 means dead. Machine learning algorithm is nominal and np. You can represent det and np by using np. And since you got the answer, you can't relax. You have to go with 4. In this case, I'll take the machine learning once, algorithm second once. I'll check whether I can represent the machine learning. Yes, you can represent the machine learning by using NP, and algorithm you can use represent by using noun. Here we got two answers. Here we can represent these two separately, but combined we can't represent. So we have to go with this one. Now, length 4. What is the machine learning? From 1 to 4, we'll check whether we can represent what is the machine learning or not. First, I'll check with what, and the rest I'll check, and the rest I'll take as 1 is the machine learning. What I can represent by ox is the machine learning I can represent by VB. That means we can represent what is the machine learning by using s. Then since I need to check whether is there any, whether I can represent what is the machine learning also. So I'll take what is as one word, the machine learning as one word, but I can't represent what is, so I'll take it null and p. Once we have null, we can't represent it. And it's okay. I didn't get for what is. Maybe I got for what is the. So I'll take 1 to 1 comma 3 and left machine learning. But I can't represent what is the also, so it is null. But we got the answer at k equal to 1, so we took that answer. Now we have to check for the remaining one. 2 to 5 is the machine learning algorithm. Split at k equal to 2. First I'll take is, and whatever the rest I'll take as 1. I can represent is. I can represent the machine learning algorithm also. The good news, I can represent the entire thing by using VP. Now split it to k equal to 3. I'll check is, I can represent is the. No, I can't represent is the. Now check 2 equal to 4. Is there any way I can represent is the machine learning? And the rest I'll take for 5 5. Yeah, you can represent is the machine learning by using VP, and algorithm you can use represent it by MP. Separately you can represent it, but the combination you can't represent it. So you have to go with the first one. Now let's lengthify the last one. Take the full sentence. Split. I'll check with what as one and is the machine learning algorithm as second one. Yes, I can represent both by using S. Now you can't stop. Let's check what is I can represent and the rest I can represent or not. What is you can't represent. It's okay. I'll check. I'll go with 3. I'll check what is the can I represent? No, you can't represent. Okay, it's okay. I'll go for 1. I- What is the machine learning? Can I represent or not? Yes, you can represent what is the machine learning by using S, and what is left algorithm. And algorithm you can represent by using nominal, noun, NP. But as I already told you, separately you can represent, but the combination you can't represent. So we go with S. That's how. After every length, we have to fill the table by augs, verb, dent, nominal. After taking every length, you have to fill the table. Okay? See, how do you know this sentence is accepted or not? Because I already told you. If the first row, last cell has contain S, S means starting variable. If it is contained starting variable, then it means it is accepted. I already told you here. If our if the sentence is derived by our grammar starting variable, then that sentence is accepted in our language, but it needs to derive with the starting variable. Other than S, if we have anything like VP, NP, verb, we can't tell it is accepted. It is only accepted when it has S. Since it is has, and that means this sentence is derived. We can derive this sentence by using starting variable of our grammar. Since we can derive, we can say this sentence is accepted. That's how we accept the things. This is a valid sentences. Like that, I like that I derived each and every 15 sentences. See here, I designed five rootable because it is five words sentence. Just like everything I derived like that. Here four. Depending upon the words, you have to create the table. Now let's like here I have six sentences. I have six words, so I create six row table. For 15 sentences, depending upon the sentences words, I create the tables and I wrote length one, length two, length three, length four, length five, length six, up to like that, and I I checked with length one, length two, length three, and I fill the table. And at the end of the first cell, if I got S, then that means I'll accept my sentence. Like that, I did for my valid sentences. Now let's go for invalid sentence. Like these are all for the valid sentences. Okay, invalid sentences. You have it out. Is there a different way for valid and invalid sentences? No. By using one way only, you can represent both valid and invalid sentences. By using CKY parser table only, we can represent valid or invalid sentences. Now check it. What machine learning is for? Is my sentence. I need to check whether it is valid or not. Okay, let's check it. First, create a table as same like that. I have I have four words, so I'll create the four row table. First, just same the process. First, you need to take the length one. Okay, I took the length ones. I can, yes, we already see we can represent what, we can represent machine learning, we can represent ease, we can represent for. All words are accepted. We may think if all diagonals are accepted in the first length, maybe it will be accepted. I already told you we can't determine in the by the first length. We have to determine at the first row last cell. So we can't any presume that. First, fill all that ones. Okay. Next, to take length two. I'll I'll check whether I can represent what machine learning is or what machine learning I can represent or not. One comma two. Augs noun nominal. I can't represent augs and noun. I can't represent augs and nominal. I can't represent augs and NP. That means I can't represent what machine learning is. You can represent what is machine learning. See, just because you deleted that verb, you can't represent what machine learning is. What is machine learning? You can represent. Just because you deleted middle verb, you can't represent this one. Now let's check whether machine learning is we can represent or not. 2 comma 3 now nominal NP is verb. No, you can't represent. You can represent is machine learning, but See, you can't, there is nothing in the world nothing in this grammar you can represent noun or verb, nominal or verb, NP or verb. But you can represent verb or noun. That's how it's work. Now let's check for to is for. Is verb, for is preposition. You can't represent it. So let's fill all the row with nulls. Now let's check. Maybe second row is null. Maybe we can accept something in third row. The three length. Three. What machine learning is. Now split it 1, 1. Take what and take machine learning is separately. What you can represent aux. We already see machine learning is we can't represent. So we can't represent it. Maybe let's check with other combinations. Maybe I can represent what machine learning and separately I can represent is. So let's check with that combination. No, what machine learning you can't represent, even though you can represent the. So that's why you have to took it null. Same, machine learning is for. Let's check first by taking first machine learning is for as one word. No, you can't represent. Maybe I'll check for machine learning is as one word for as another word. Machine learning is you can't represent. It is also empty. Maybe all these are empty. Maybe I can represent what is machine learning for. First check, take what as one word. Machine learning is for second word. No, you can't represent it because machine learning is for you can represent it. It is empty. Okay, let's take what machine learning is one word is for as another word. Both you can't represent it. Both are empty. Okay, let's take what machine learning is as one word for as one word. What for you can represent by preposition, but what machine learning you can't represent, so it is empty. Now let's check whether this sentence is accepted or not. No, the sentence is not accepted. Not because it has null, because the sentence is not started with it now. It doesn't have S. Even if the cell 1, 4 has VP, NP, noun, nominal, verb, anything it can have. But if it does not start with starting variable, you can't represent it. Since it does not start with S, I can assuredly say it is rejected. You can think it is null, that's why it's not rejected. No, I already told you. Our grammar has to derive from the starting variable. If it is not derived from the starting variable, then I can assuredly say that the language or that the sentence is not accepted in our language. So this grammar, it is not started with S and it is empty. That's why it is this what machine learning is for is not accepted in our language. Just we just changed their placements since it's not following the grammar rules. Every word is present in our what is present. Machine learning is present, her present. But still, didn't accept it? Because everything is present, but they are not following the proper rules. Here we can't have noun and verb. We can have verb and noun, but we can't have noun and verb. So if it is not following the rules, it can't be accepted. It can't be derived from by the starting variable. So it since it is not derived by the starting variable, I can say this cell is not accepted. This sentence is not accepted. Like that's how you need to. That's how I did all my three sentences. Here now by using CKY parser, that's how you decide whether you can derive or not. Sorry, by using CKY parser, you can decide whether these sentences what belongs to our language or not by starting variable. Thank you very much.